Hi everyone, this is Bhavani from CSC Regular. My guide teacher is Raju sir. Today I'll be presenting my PPT on Norton's theorem. Firstly, Norton's theorem is a basic principle in electrical circuit analysis. It helps us in simplifying the complex electrical circuits. By the end of this PPT, you will understand how it converts those complex electrical circuits into simpler ones. First, we shall see the statement of this theorem. According to this theorem, any linear bilateral network containing various voltage and current sources can be replaced by an equivalent circuit consisting of a single current source IN and which is connected in parallel to a resistor RN that is connected in parallel to load resistor. This equivalent circuit is also known as Norton's equivalent circuit. As you can see here, this linear network is transformed into this just containing a single current source which is connected in parallel to a resistor. IN is known as Norton's current and RN is known as Norton's equivalent resistance. IN is also known as short circuit current. We will find IN by short circuiting this load resistor. That is by replacing this load resistor with a wire and we will find out the Rn by finding the equivalent resistance across these terminals AB after deactivating all the voltage and current sources present in this linear network. We can deactivate the sources by replacing them with their internal resistances. That is, we will deactivate a voltage source by replacing it with a wire, that is by short circuiting it, and we will open circuit all the current sources. Any circuit that satisfying the conditions that I stated before can be converted into this simpler Norton's equivalent circuits by following this procedure. Step 1 is to find the Norton's current. To find the Norton's current, first we have to short circuit the load resistor. That is, we have to replace the load resistor by using a wire, and then we have to find the current passing through that wire. We can find that current by using any of the methods we know, like by applying KCL or KVL or superposition theorem or by Ohm's law, anything. The current obtained is nothing but Norton's current. Since we have the Norton's current, we have to find the Norton's resistance. To find that, we have to first deactivate all the voltage and current sources as I said before, and we have to find the equivalent resistance across the terminals AB which we short circuited before. The resistance obtained is nothing but Norton's equivalent resistance. Since we have Norton's current and Norton's equivalent resistance, we can draw the Norton's equivalent circuit. And finally, we can calculate the current passing through that load resistor. Now we shall see this example for a better understanding of this theorem. Here in the circuit, it contains a current source and a voltage source and some resistors. Here this 50 ohm is our load resistor. We have to find the current passing through this 50 ohm using Norton's theorem. The first step is to short circuit this load resistor and find the current passing through this terminal AB. On short circuiting that load resistor, we get something like this circuit. Now we have to find this current. To solve that, I'm using mesh law. I'm assuming that I1, I2, I3 are the clockwise currents flowing in these three loops. From first loop, we get I1 is equals to 10 amperes. From this loop 2, we get 60 into I2 minus I3 minus 50 plus 20 into I2 minus I1 is equals to 0. From this loop 3, we get the equation 40 into I3 minus I1, 60 into I3 minus I2 is equals to 0. By solving these three equations, we get the values of I2 and I3. Here I3 is nothing but the current passing through this terminal AB. That is nothing but our required Norton's current. Now to find Norton's resistance, We have to find the resistance across AB after deactivating all the voltage and current sources. After deactivating this voltage source, we get something like this. That is, we are short circuiting it and we are open circuiting this current source. Now the equivalent resistance across this terminal AB is nothing but the 60 ohm and 20 ohm in parallel connection that is connected in series with 40 ohm resistor. After solving, we get the resistance across AB is 55 ohm. That is nothing but Norton's equivalent resistance. Since we have the both Norton's current and Norton's equivalent resistance, we can draw the Norton's equivalent circuit, which will be something like this. It contains a current source of IN is equal to 10.7 ampere, which is connected in parallel with a resistor of resistance 55 ohm, that is connected in parallel with a 50 ohm resistor. Now, to find current passing through this 50 ohm resistor, we can use this current division method. From that, we get it as 5.604 amperes. That is, the current passing through the load resistor 50 ohm is 5.604 amperes. Now we can see how this complex circuit got simplified into this circuit. It was easier for us to calculate current passing through this 50 ohm resistor in this circuit than in this circuit. Now, the advantages of Norton's theorem are it simplifies complex networks, it reduces computational complexity. As we saw earlier, how that uh, complex circuit was transformed into a simpler circuit, which made helped us in simplifying the circuit in an easier manner, which was time saving for us. And the disadvantages of this Norton's theorem is it is applicable only for linear networks and it does not account for non-linearities. That is, non-linear elements as power cannot be calculated by using this Norton's theorem. These are the only disadvantages of this Norton's theorem. I hope now you understood how Norton's theorem helps us in simplifying the complex circuits. Thank you.